Welcome to this pre-lab video. This is the pre-lab video for our in-person lab on the group 1 cations qualitative analysis. Now, this lab is different in very, very many ways from other labs that we've done this semester. Most of the labs that we've done this semester have been of a quantitative nature, where we've been measuring things in terms of numbers and changes in concentration, pH values, those kinds of things. Um, this is different. This is going to be purely qualitative, meaning we're going to be looking at observations, looking at observable events, and trying to rationalize and make predictions and conclusions off of those observations. So, just a little bit of background here. We want to look at this particular lab, and in terms of labs, the objectives of the lab are about identifying the ions of group 1, showing their reactions and how we separate them. And if you get into the discussion talks a little bit about this, but I'm going to illustrate. I think it'll help a lot to see what this is all about. So the whole point of qualitative analysis, and that is what we are doing, is this. We're doing a process that uses something called selective precipitation to separate ions of different metals from each other. And selective precipitation takes advantage of the solubility, or lack thereof, of certain substances in water. So if we kind of think about this as a large overarching picture, up here at the top, we can think of all cations. And if we do it from that perspective, we've got everything in here. We've got ammonium ion, we've got barium ion, we've got we've got copper ions, we've got silver ions, we've got any ion that you can think of. Well, in a series of stages, we can separate these ions from each other based upon their selective solubility. The first step that we would do is the addition of hydrochloric acid, and that would split off what we call the group 1 ions, which would include the silver ion, the lead 2 ion, and the mercury 1 ion. And this is the focus of the discussion today. The remainder of the field goes here. And then we can split it off in terms of other kinds of reactions. And so based upon this concept of selective solubility, we can more or less split up the cations into 4 different groups. The ones that are insoluble in chloride solutions, that's again the silver, the lead, and the mercury 1. Those that are insoluble in acidic sulfide solutions, these would be the group 2 cations. In here, you'd find things like remainders of lead, mercury 2 plus, copper, nickel, and some other ones as well. Not, I guess not nickel, but you find some other ones in here as well. In the group 3, this is where you would find your nickel. This is also where you would find things like manganese, and tin, antimony, those kinds of things. And then the group 4s are kind of the ones that we usually need flame tests for. We're talking about ammonium ion, we're talking about barium ion. So a lot of your group 1s and group your alkali metals and your alkaline earth metals. Now again, in previous semesters, we would have explored this a lot more closely. We didn't have the time this semester to do that because we had a limited number of days. And the group 2 analysis, for example, is a good solid 2-day procedure just to do the known, let alone the unknown. And the group 3 is similarly long. But the group 1 we can actually do within about a day. If we have a really good day, we could actually not only do the group 1 analysis, but we could also do an unknown analysis with this as well. And so if we look more closely at the chart, what we're going to see here is that we've got 3 ions in particular. We've got the silver ion, we've got the lead 2 ion, and we've got the mercury 1 ion, Hg22+. Now, when we expose them to hydrochloric acid, they will turn into solids: silver chloride, lead 2 chloride, and the mercury 1 chloride, Hg2Cl2. From here, we can actually separate them based upon solubility in hot water versus cold water. The lead 2 chloride is much more soluble in water than the other 2. And so we can split it off over here, get it back into solution, keep the silver chloride and the mercury here, and then using ammonia, we can split this off into the silver complex, and the mercury actually goes through a reaction where it splits off into mercury 1 and, or excuse me, mercury 2 ion and the metallic mercury 0. And so from this standpoint, we now have all 3 of them separated from each other. We can use something like HCl to get the pH back down to recreate the silver chloride there again. And that's more or less what you're going to do in this procedure. So the main point of the first day of the procedure is to go through this process and to just see, okay, this is what happens when I do this. This is what happens when I do that. These are the kinds of reactions that are going to take place. The point of the second day is we will give you a solution of an unknown nature that is going to contain a combination of these ions. And your job will be to identify, okay, this ion's present and this one's not, and here are the reasons why. Now, this presents some different kinds of things for us compared to what we have done in the past. So if I go over to Lab Archives now, I can see that there are some things here that are different. So first of all, the procedures are set up. Again, you can see that it's very, very easy to kind of point out. You'll notice that there are some things that I did neglect, in particular, things like definitive testing. So once we have removed the lead from the reaction by using the hot water, we're going to actually do a test with it by exposing it to the chromate ion. which will turn it into lead 2 chromate. Which has a very, very definitive kind of yellow color to the solid. And for the silver ion, I misspoke in the previous. We're actually going to use nitric acid, not sulfuric or not hydrochloric acid. We don't want to introduce extra chlorides. That might confuse the reaction. But in doing this, we'll take it from the complex form back to the AgCl that we had, and basically acidifying those two ammonias that get attached. So there is a little bit of do this, verify that what you see is actually what you're supposed to see kind of thing. But what I wanted to point out to you here is your notebook procedure is going to be very, very different. Unlike in the past, where you've basically just had to drop some stuff into data tables and kind of go on your way, you can see that this is a little bit different. We've got a form, a structure that we are working within. There is a procedure section. Here's what I'm supposed to do. Here's what I saw. Here is what it means. Here are the reactions that took place in this particular step. And you're going to follow this procedure throughout the work of the known that you're going to do this week. But notice that for the unknown, we've stripped all of that away. You are going to have to fill in the sections of your unknown notebook following this same format, but without the help of that template. Now, some of it is going to be literal copy and paste, but how you choose to construct your notebook is going to be kind of up to you. Notice also that you're going to write your own conclusion. So one of the things that we're getting after with this particular lab is trying to foster a little bit more of independent thought, independent practice, independent procedure in you. For the unknown analysis, this unknown analysis is actually your quiz for that lab. So your instructor is going to be somewhat limited in how much they can help you with the procedure and interpreting the results. They can give you some guidance. They can tell you a little bit about what's going on, but ultimately it is a quiz, and they are going to be limited in terms of telling you how correct or incorrect that you are. So please keep that in mind. Now, there is in this assignment a bonus assignment that goes with it as well. What you need to do in the bonus assignment is you will need to look at what is being done here, and you're going to use your knowledge, not only the knowledge of the experiment that you just did, but also the knowledge of, well, your other things, your rules of solubility, for example. Use this to determine which of these compounds are present or absent and give a reason why. Every compound that you get correct is worth a point. Every reasoning that you give is also worth a point. So you've got 8 bonus points out here just waiting to be taken for this experiment. And so from that, let's look at the pre-lab real quick before we close it up for the day. And you can see that the pre-lab assignment, lists the ions on this group. We've already gone through that. There are only 3 in this. It is the silver ion, the lead 2+ ion, and the mercury 1 ion. What reagent is used to separate the ions of this group from the other cations? Well, we know that this is going to be 6 molar HCl. You are going to have to write the equations in here. I will not give them to you, but I would direct you toward this little page here, which tells you all of the equations that you need for the experiment. And then these come as just a matter of, can you read through the procedure and find the answers? So which precipitate is soluble in hot water? We already discussed that before. It's the lead chloride. But show the equation that goes to that. And again, I would point you to this right there. What happens to the remaining precipitates? Again, the procedure should give you an idea of what to expect in terms of not only chemical reaction, but observation. And the equations list right here should give you the actual equations that you need. And the same thing with this question here about the chromate ion. The procedures will tell you when that chromate is used, should tell you what color the precipitate is. You just need to find the information. So, these labs are kind of fun. And even though we're not going to do the ones that really get into some pretty cool transition metal chemistry, this is still a pretty fun lab. And you should have, you should be able to do this relatively easily and get some pretty easy points for it if you do the notebook correctly. And if you have any questions about the notebook itself, drop me a line. I'll be happy to help you. But that's all for this video for today. So without further ado, I'll see you next time. Have a good day. See you in lab.